Happy 2013, everyone. We're just going to I always say quickly, go over the Unit 5 review. You'll see a video for each problem to make your life a little bit easier. If you haven't scouted out the review or know where to get it, I would say just read these problems, pause the video, and try it out yourself before you hear the explanation. So, problem number one. I'm going to kind of follow the same routine for each and every one of these problems. You'll notice that I'm going to basically start with our new equation for Unit 5, Newton's second, and then go from there. You're going to see some substitutions that we're going to have to make, but they're all based upon your force diagram. Draw a good force diagram, and you basically win at life. So, a good force diagram in this situation is this for number one. We have the box by the floor. We have two of those, an Fn pushing up, an FFK going to the left. We have an FT on the box by the rope, which is broken up into its components. We know that that's 30 degrees right there. And the nice thing that I notice is I know this tension, so technically I can use the SOHCAHTOA and solve for both of those. So I'm going to put little smiley faces next to them just to remind me that I could get those really easily. The other thing that I always like to note, and this is something that throws a lot of students off, is that because I know that it is not accelerating up or down, the force up equals the force down. So we have two forces up. Fn on the box by the floor and the FTY, those two have to equal my FG. The other thing that I know is it's accelerating to the right, and because it's accelerating to the right, I know that my FTX is larger than my FFK. I circled what we call the net force. The net force is the amount that one side is winning by, and in order to solve that, I'm going to do FTX minus FFK in order to get that. So you realize that basically I've sorted out two equations that come straight from my force diagram. Also noting that I have some SOHCAHTOA, which means I could do an equation to solve for this guy, and I can use an equation to solve for that guy. If you are comfortable with all of that, the rest of it is just going into our Newton law of A is equal to the net force divided by the mass of the system. And so I know A, so I know that's not a problem. I know the mass of the system, so I know that's not a problem, and it's all around the net force equation. And so basically what I want to do is try to solve for my net force. In order to do this, we know it's FTX minus FFK, and this is equal to mass of the system times acceleration. I'm happy with the left-hand side because I have both of those, and now basically it's just working with all of this stuff on over here. FTX I said I know, so I'm happy with that one, so it's all going to be circling around FFK. FFK in this example is equal to, using our equation, mu sub k times Fn. And I know Fn, hey, look back here, I know Fn is equal to Fg minus Fty, so I'm going to run that substitution now too. So we have mass system times acceleration is equal to Ftx minus mu k, and Fn is now going to be rewritten, and I put this in parentheses because it is one term here. It is going to be rewritten as Fg minus Ft. Ty. And ladies and gentlemen, I can solve for Fg. Fty, I said I can solve for. Mu sub k is not something that I don't know. I have that, I have that, and I have that. So, you basically have the final answer if you would have just written this piece right here. Now all it takes is just plugging in your numbers using some SOHCAHTOA and all that other good stuff. I'll let you take a shot at that. I believe I have an answer here. It's 0.694. Don't hold me to it. I did that very quickly. Try it out yourself if you have any problems. Let me know about the math, but that is how you would solve for it. Again, aiming for that mu k. So, moving on to number 2 in the next video. See you there.